Week 1, Introduction to Docker. Introduction to Docker. Docker is a platform that allows developers to easily build, ship, and run applications as containers. Containers are lightweight, portable, and self-contained environments that bundle together all the necessary dependencies, libraries, and configuration files required to run an application. Docker provides a standardized way to package and distribute software applications, making it easy for developers to deploy their applications on different environments, such as different operating systems or cloud platforms, without having to worry about compatibility issues. One of the key benefits of Docker is its ability to enable efficient and scalable deployment of applications. By using Docker containers, developers can easily replicate and scale their application across multiple servers or machines, allowing them to handle increased traffic and demand. Docker is also open source, which means that it is free to use and can be customized to suit the needs of individual developers and organizations. Docker has a large and active community of developers who contribute to its ongoing development and provide support through various forums and channels. Overall, Docker is a powerful and flexible platform that has become an essential tool for modern software development and deployment. What is containerization? Containerization is a process of packaging an application and all of its dependencies into a single, portable unit called a container. Containers are isolated from each other and from the underlying infrastructure, allowing applications to run consistently across different environments. Containerization allows developers to package their applications and all the necessary dependencies, libraries, and configuration files into a single, self-contained unit. This makes it easy to deploy the application across different environments, such as development, testing, and production, without having to worry about compatibility issues or dependencies. Containers are also lightweight and efficient, using shared resources from the underlying infrastructure, which makes them easy to deploy and scale. They are also more secure than traditional deployment methods because they isolate the application from the host operating system and other containers running on the same system. Docker is one of the most popular containerization platforms, providing tools and services that allow developers to create, package, and deploy their applications as containers. However, there are other containerization platforms and technologies available, such as Kubernetes and Apache Mesas, that provide similar capabilities. Benefits of using Docker. Docker provides several benefits that make it an attractive option for developers and organizations. 1. Portability. Docker allows applications to be packaged and shipped as containers, which can run consistently across different environments, such as different operating systems, cloud platforms, or development machines. 2. Efficiency. Containers are lightweight and use shared resources from the underlying infrastructure, making them easy to deploy and scale. 3. Isolation. Containers provide an isolated environment for applications to run, which improves security and eliminates compatibility issues with other applications running on the same system. 4. Consistency. Docker ensures that applications run consistently across different environments, which helps to eliminate errors and improve reliability. 5. Modularity. Docker allows developers to break their applications down into smaller, modular components that can be developed, tested, and deployed independently. Overall, Docker provides a powerful and flexible platform for modern software development and deployment, which can improve efficiency, reliability, and security for applications. Docker architecture. Docker architecture consists of several components that work together to create and manage containers. 1. Docker daemon. The Docker daemon is a background process that manages the building, running, and distributing of Docker containers. It runs on the host operating system and communicates with the Docker client and other Docker tools. 2. Docker client. The Docker client is a command line tool that allows users to interact with the Docker daemon. It sends commands to the daemon, which executes them to create and manage containers. 3. Docker images. A Docker image is a lightweight, read-only, and executable package that contains everything needed to run an application, including the code, libraries, dependencies, and configuration files. 4. Docker registry. A Docker registry is a repository where Docker images are stored and distributed. It can be a public or private registry, depending on the needs of the organization. 5. Docker container. A Docker container is a lightweight and portable executable package that contains everything needed to run an application, including the code, libraries, dependencies, and configuration files. Each container runs in an isolated environment and has its own file system, network, and resources. 6. Docker Compose. Docker Compose is a tool that allows developers to define and run multi-container Docker applications. It uses a YAML file to define the services, networks, and volumes required by the application. 7. Docker Swarm. Docker Swarm is a tool that allows developers to create and manage a cluster of Docker nodes. It provides orchestration and clustering capabilities, allowing developers to scale and manage containers across multiple nodes. Overall, Docker architecture provides a powerful and flexible platform for creating, managing, and deploying containers. It allows developers to build applications that are portable, efficient, and scalable, which can improve efficiency, reliability, and security for applications.
Thanks for watching. For more information, like, comment, and subscribe our channel.